So today I wanted to go over single phase half wave rectifiers. In the next video we're going to look at single phase full wave rectifiers. In this one we're just going to concentrate on the basics and just do the half wave rectifier and kind of dissect it so we can better understand. So right here this is just a very basic sine wave. Here is your period, which would be your time, and then to the left that's going to be your magnitude of your voltage. So in this one we're going to just do the max voltage. So this here will be your peak. Now the one at the bottom, that's going to be your negative peak. Right now we're just going to focus on the positive. Now I'm going off of the assumption that you've already taken your Calc 1 and maybe Calc 2 courses already. So this should be relatively easy for you to grasp. So we're going to be looking for Vmax. So as you know, Vmax is equal to Vrms times the square root of 2, or Vrms is equal to Vmax divided by square root of 2. For a one time period sine wave, you're going to have the 0 to 2 pi. So you can see at the beginning we have 0, we cross at pi, and we end at 2 pi. So keep in mind this is in radians. So everything that we're going to be calculating is in radians, not degrees. So if your calculator is set to degrees right now, you're going to get the wrong answers. So what we're looking for is the single phase half wave rectifier, DC voltage output. So the formula for VDC out, which is what we're looking for, the DC voltage out is equal to 1 over 2 pi times the integral of Vmax times sine theta. What this formula is showing us is we're looking for the area, and we're going to divide the area by the period, which is 2 pi. So this portion would be the area under the curve, and we're going to divide that area by 2 pi. Again, we're only looking for the halfway rectifier, so we're not going to be focusing on the negative part. So let's start by dissecting just the integral part. Now, some people shy away from this, but calculus is very easy. So keep in mind we're radians only. So if you're in degrees now, would be a good time to change that over to radians. So let's just go step by step. Again, we're looking between 0 and pi. So let's go ahead and bring down 1 over 2 pi times the integral of Vmax times sine theta is going to be Vmax times negative cosine theta. And then again, we're going to be looking between 0 and pi. So we'll just bring this down, 1 over 2 pi times Vmax minus cosine pi minus Vmax times negative cosine 0. Now remember, a negative and a negative equal a positive. So let's clarify that and rewrite it. So 1 over 2 pi again times Vmax times negative cosine pi plus Vmax cosine 0. So now we can rewrite this. And again, all we're doing is we're just bringing down the 1 over 2 pi. We really aren't doing anything with that. We're just concentrating on the integral part and going step by step. So now pulling out the Vmax, we get 1 over 2 pi times negative cosine pi plus cosine 0, all times Vmax. Now at this point we can go ahead and just calculate the cosine pi and cosine 0. Now again, keep in mind we have to be in radians for both. So once we calculate that, we're going to have 1 over 2 pi times 1 plus 1 times Vmax. Now we can solve it out. The VDC out is going to equal 2 over 2 pi times Vmax, which is going to equal 0.318 times Vmax. So we can put any Vmax value here, any peak value, take it and put it into our Vmax, and we're going to find exactly what our VDC out for this single phase half wave rectifier. In the next video, we're going to take a look at the single phase full wave rectifier.